So the next type of function adapter we're going to talk about are the member or pointer to function adapters. And these can be used to allow class member functions or C style functions to be passed as arguments to STL algorithms. And you'll see that there's several of them. There's memfun, memfunction or memfn, and pointerfun. Memfunction is really the one that's now the designated one to use. The other ones have been deprecated, and you'll see you don't really need to have them anymore. So let's go ahead and take a look at first the pointer to member function adapter examples, and then we'll return and talk about the other types in just a second. So now we're going to talk about different types of member function adapters, and these can be used to enable C++ class member functions to be used as arguments to C++'s algorithms and other things that you might need to use them for that are like the predefined algorithms. So there's really three of these. There's memfun, memfunref, and memfunction or memfn. Memfun and memfunref have been deprecated. Memfunction has taken over and is designed to be used for modern versions of C++. So let's go ahead and take a look at how to use this. And it's really interesting and comes in very handy if you have a lot of C++ classes where you want to use their member functions in a context where you need a regular good old STL algorithm. So to showcase this, we're going to define a little class called wrapInt. And wrapInt is kind of like the Java boxed types, so integer, long, double, and so on, with capital I and capital L and capital D and so on, where they wrap a native data type. So you can use them in Java. You have to use that if you want to do things like parameterized types and generics and so on. In C++, you don't need that as much, but you still might want to wrap things for various reasons. So here we're going to have wrapInt's constructor, which just sets the value, which is in this case an int, to 0. We have a constructor that creates a wrapped int from an int. And then we have various methods like showval, isPrime, isEven, isOdd. And you can see that isEven and isOdd and isPrime were defined as no discard, which says you've got to check the return values here, because that's the whole point of these functions, to return something you can do something with. And the isPrime does just a deliberately inefficient check for a prime number. IsOdd, isEven, return true or false if something's even or odd. So here's our program. And you can see here that I must have increased this thing to C++ 17. Let me back off C++ 17 for a second and go to C++ 14. It's kind of funny. So these deprecated operations, you can see here, for example, that if you go too far and crank the compiler version up too far, they've really taken those methods out, so they've been removed. So you can get them back if you use a flag to the compiler to use deprecated functions or something like that. But let's just keep it in C++ 14 for now to make it work. We make ourselves a vector of wrapped ints of size 10. We then create an instance of wrapInt, and then we go ahead and call its isEven method. And I did this on purpose just to show you what happens if you don't check the return value, and you can see that it's not going to like this. It says ignoring return value of function declared with no discard attribute. So it's like, don't do this, dude. So let's go ahead and just for kicks, well, we can just ignore that. It's just a warning, but you're not supposed to not check the results of no discard. We then go ahead and iterate through the loop from I equals 0 to I less than 10. And we're going to go ahead and create wrapped ints with the value 1 through 10. And then we go ahead and use some existing STL algorithms. So we're going to use the for each algorithm. And we want to go through that vector from beginning to end. And we want to end up calling the showval member function on every element in our vector of wrapInt objects. And the way we do that is we use the memfunref function adapter, which goes ahead and creates an object called const memfunreft, which is going to end up basically holding that pointer to the member function so it can be called on every element in that range. And so if you take a look here, this is allowing us to use a member function in a context where we're expecting to have an output iterator. So we're turning the member function into an output iterator for the purposes of printing the values. Well, we can then show off some other cool things. We come in here and we create ourselves an auto iterator where we go ahead and remove anything in the range that is prime. So we're going to get rid of all the prime numbers here. And then we go ahead from the beginning of the vector to the new end iterator, NP, and we go ahead and show the results. So that prints the results. And I guess if we were really being formal, we should then say a vector dot erase NP avec dot end. So now we've gone ahead and removed those elements once and for all from that range. The next thing we do is we go through this and we make a new vector from 1 to 10, same thing as we did before. Probably could have stashed that away somewhere and just copied it, but we just do this again. And then we go ahead and we remove all the even numbers. Same basic idea. We go through and we get back a new end pointer to the range after we've removed the even numbers. And then we go and print out the contents using our good old for each loop as before. And just to remind you very quickly what for each actually does, under the hood, what we'll see for each do is it's going to iterate through every element in that range. And for every element in the range, it's going to go ahead and call the function that's passed in, which in this case is a unary function for each element, which, as we saw, is going to go ahead and call the show value or is even, it'll call the show value operation on every element in that range. Then once again, we'll erase the contents just for kicks, recreate our array. This time we're going to get rid of all the odd numbers. And I think you kind of derive the pattern that we're doing here. We're going through these things and modifying them. In this case, just for kicks, we're going to go ahead and we're going to use a Lambda function instead of using the memfunref adapter. So in this case, we're just going to pass in a reference to a rep int, and we're going to say wi.showval, and that'll go ahead and print the results. So that's just maybe it's more concise, maybe it's not. I think it's actually a little more concise to use the memfun or memfunref adapters. And oh, by the way, I should have mentioned that here we're using memfunction or memfn, whereas up here we're using memfunref. The difference is that memfunref has been deprecated in newer versions of STL. So you really want to use memfunction for this kind of purpose.